So we're going to be looking at integration by parts now. Integration by parts. I bet you might be confused, so you might be wondering, how do I solve a question that says use integration by parts to solve? Okay, mostly universities they make use of solve using integration by parts. Okay, now let's look at our product rule. For integration is gotten from product rule. Let me show you now. We have d into bracket uv over ds is equals to u dv ds plus v du ds. Remember, this is product rule, is that not? Okay, you can recall. Okay, mind you, this is product rule. Now, what did integration by parts simply means? Now, when this is u dv, uv in respect to s, now we have u dv over ds respect to s and v du. This could also be if we multiply all through by integral. That means integration. If I should integrate this, and integrate this, I have something like the integral of d uv in respect to s is equals to integral of u dv ds plus the integral of v du with respect to s. Okay, from this now, if I should integrate this, it's as having the integral of uv and if I should integrate this, I should have integral of u dv, this is the same thing as dv dx, plus integral of v du, same thing as du ds. Now I want to take u to this place and factor out this, and I want to make u dv the solvent of the formula. To make this solvent of the formula, I'm going to take this here and bring this there. So now, while doing that, the v, now I'm going to take this to the other side. uv minus integral of v du. Now this is what we know as integration by parts. Hey! Integration by parts. Are you following? So questions like this, I'm going to show you an example on how we make use of integration by parts and how we can solve it using what integration by parts. Watch me as I solve. Dear viewers, if you're included in topics like trigonometry, vector, calculus, both differentiation and integration, machine, cyclic theory, electronics, Laplace, so on and so on, here in mostly electrical physics or mathematics courses, we have them for you. You are the right channel, don't miss out. Find S cos S using integration by parts. Now, once you solve a question like this, remember the formula for integration by parts says the integral of u dv is equals to uv minus the integral of v du. So, having that, Looking at s cos s, we assume u to be s and b to be cos s. So now, since we get that, we can say u is equals to s, and if you find the differentiation of u, that is du in respect to s, we have it to be equals to what? 1. S will become 1. How come? S here is having an invisible raised to power 1. Because anything raised to power 1 is what? Still that same number. Right? S raised to power 1 is S. So if I should remove 1 from here, and this same 1, I used to multiply this S, the coefficient of this S, that is this same raised to power 1, I used to multiply this S, and I remove 1 from this one side. So I'm going to be left with 1 times S is S, but 1 minus 1 is what? 0. S raised to power 0 is what? Is 1. So du ds of S will give us 1. So we have du ds equals to 1. That is to say, du, if I should cross multiply, du is equals to ds times 1, that is ds. So whenever I see du, I'll put ds. Okay, having that now, what is b? B is the integral of this, and that is cos s ds. Okay. And what is u? What is integral of dv ds? That's going to give us cos s ds. Let me just say dv rather. Dv. Because of it's going to give us dv ds equals to this. But if I should cross multiply, dv will be equals to cos s ds. Why? This multiplied by this cos s ds. Okay, now this solves now. The moment I can get this, I know that u is s and b is the integral of cos s, and dv ds will be cos s, and du ds is 1 when you differentiate this s. Then I can now equate it into this alphabet. Okay. For instance, we are having our formula to be u dv equals to uv minus the integral of b du. Now, integral u is what? U is s. dv is what? Cos s ds. Can't you say it's the same thing with this s cos s and integral of it? Can I say that's like we are correct? Okay. U is s and integral of this. So into bracket b is this. The integral of cos s ds. Okay. Minus the integral of this. B is what? B is still the same integral. Into bracket another integral again. Cos s ds. And du is what? Du is ds. So ds. Instead of me to write du, I write ds. Okay? Because du is equals to ds. Now, with this, we have the integral of this is equal to this. Now, if you integrate cos s, the integral of cos s ds is equal to what? Is equal to sin s. Now, So anyway, we see the integral of cos s, now is what? Sin s. So now from here, the integral of this, integration of this, is equals to s, and the integral of cos s is what? Sin s. So I'm going to put my sin s minus integral into bracket. The integral of cos s is sin s ds. So if I should open this, it simply means s sin s minus integral of sin s ds plus constant c. So the integral of sin s, so if I should find the integral of sin s ds, it is equals to minus cos s. It means that the integral of cos s is what? Sin s. Sin s is what? Minus cos s. Why? For differentiation, cos s will give us minus sin s, and sin s will give us cos s. That is opposite of each other. Differentiation is opposite of integration, as we all know. Okay. So with that, s sin s minus into bracket minus cos s plus c. S sin s minus times minus plus cos s plus constant c. These are our final answer. Now, how do we check if it is correct or not?